Hi everyone. Today we will discuss electric field. In previous class we learnt about the properties of electric charge and Coulomb's law of forces. So that is repel force or attractive force and the forces between multiple charges. Today we will discuss electric field. So electric field is nothing but the space around the electric charge up to which its influence is known as electric field. Okay, the space, for example, we are consider a positive charge. This positive charge is influences it produced in electric field. It is called the source charge, and here a positive charge or negative charge of it is influenced about the source charge is called the test charge. Okay, here we are consider a positive charge, then this positive charge is influenced certain space, okay, space around it. For example, we are kept a negative charge in this space, in this electric field. What happens? The attraction force between plus q and minus q. Okay, when we kept here a positive charge, positive plus, so plus q, and this plus q and plus q, it is repelled to each other. The repulsive force is occurred in these two charges. So for example, a minus q negative charge is kept at this position, at this point. What happens here? The no force is occurred, either positive charge or a negative charge. So that is on the negative charge there is no attractive force is occurred because the field is influenced of this charge is only up to this only. It is not influenced on this negative charge. Okay, so this is about electric field. Electric field, the space around the electric charge, okay, any source of charge is influenced around certain space, it is called the influence, so it is called the electric field. So this electric field is a conservative field. Okay, for example, we are consider different here minus q is plus q and here and different. So this electric field is denoted as E bar. Okay, so here this electric field is a conservative field. Conservative field is nothing but, so electric field of multiple charges, multiple test charges, so then total electric field of the net electric field is conserved. Okay, it is now intensity of electric field. So what is intensity of electric field? Intensity of electric field is nothing but the force experienced by unit positive charge. Test charge is placed at that is called as intensity of electric field. So here intensity of electric field is also called the electric field strength. So here intensity of electric field is also called as electric field strength. Electric field strength. Okay, this is E, electric field strength. So now intensity of electric field is also called as a electric field strength. So here the intensity of electric field or electric field strength, so E is nothing but E equals to the force experienced by a positive charge, Okay, a positive test charge, so is called the electric field strength. Electric field strength E bar equals to F bar by Q. So here Q is the test charge and capital Q is the source charge. So what is test charge? Test charge is nothing but the effect of a source charge. A charge is effect on source charge is called the test charge. And what is source charge? Source charge is nothing but the charge is produced electric field. A charge, a positive charge or a negative charge. So we are consider here positive charge. A positive charge capital Q is produced certain electric field. It is called the source charge. Here source charge is plus Q. So what is test charge? The unit charge is influenced of source charge is called the test charge. It is test charge. Test charge is Q. Okay. Now, so we are derive the equation for the electric charge. Okay, sorry, intensity of electric field. We know that the force, the attraction force, for example, this is test charge, this is test charge. So when negative charge, the test charge is negative charge, negative minus Q. So the attraction force between capital Q and minus Q. And when it is taken a positive charge plus Q, the repulsive force is occurred according to Coulomb's law. So according to Coulomb's law, F equals to, we will consider a source charge is plus Q. So F equals to, so what, 1 by 4 pi epsilon naught here plus Q, and here capital Q, these are kept in a free space. Then F bar equals to 1 by 4 pi epsilon naught into Q small q by R square into R cap. So this is equation number 1. So it is also written as F bar equals to 1 by 4 pi epsilon naught into Q small q by R cube into R bar. So here, since R cap equals to R bar is nothing but it's the vector, okay, position vector divided by, so modulus of R bar, so it is a magnitude, it is a scalar. So unit vector R cap equals to R bar by mod of R bar is nothing but small r. So then F equals 1 by 4 pi epsilon naught q by R cube into R. So this is equation number 2. Okay. Now, so electric field is nothing but, so electric field, okay, electric field strength or intensity of electric field strength E equals to F by Q, okay, F bar by Q. So Q gets cancelled. So then 1 by 4 pi epsilon naught into Q by R square, okay, into R cap, or it is also written as, so E bar equals to 1 by 4 pi epsilon naught into capital Q by R cube into R bar. So this is also one expression, okay. E bar equals 1 by 4 pi epsilon naught Q by R cube into R bar. So this is an expression for the electric field strength, okay, electric field strength. So the units for electric field strength, so it is a vector quantity. So because of the force is a vector quantity, so here the electric field strength also a vector quantity, it is a vector quantity. Next one, units. SI units for this electric field strength is Newton per coulomb. So are the units also we have taken volts per meter. So we can discuss in this units in next chapter. So then the units, SI units for electric field strength or intensity of electric field. So Newton per coulomb, or so here volt per meter. So here electric field strength is the direction of the electric field strength. So is the direction, okay, the direction along which a free positive charge experiences the force electric field in the electric field, okay, for the test charge. So it is when the test charge we have taken, the test charge is positive, then electric field strength direction is outward direction. When a test charge is taken negative, then the direction is a inward direction to the this charge. Okay, here for a positive charge. So next topic is electric field due to a system of charges. So here we consider a system of charges, okay, q1, q2, q3, so on, qn. Okay, so with position vectors r1, r2, so on, rn. So related to the origin, so we consider a origin, so r1, r2 and rn. So here this is point P, a test charge, and the source charges are q1, q2, q3, q4. Okay, at point P, a test charge, this is a positive test charge or negative test charge. So here the distance from r1, the position vectors are taken r1, r2 and rn. So these are the position vectors. So now at P point, for q1 charge, source charge, so what is the electric field? So E1 is the electric field, and for q2 source charge, so the electric field is in this direction. Okay, the electric field is in this direction. Here we consider it is a positive charge. For a positive charge, so here the direction is E2. So E1 and E2 both are the sides of parallelogram. Then the resultant, okay, here the resultant electric field strength is in this direction. So this is the resultant electric field. And so for q3 charge, the electric field direction is E3. Okay, electric field strength is E3. So this is the one side, this is another side. Okay, what is that? Here at this point, these are the diagonals of parallelogram. Then the resultant one, it is a resultant, and this resultant is a side of another parallelogram. And for the q4 charge, So E4 is a electric field strength. So then this one side and this another side, then the parallelogram, complete parallelogram, the total electric field E is a resultant vector of this parallelogram. Okay, so then for first of all, for E1 electric field E1 at small r due to Q1 at R1 is, so R is the position vector from the origin, point P from the origin. R is a position vector, and Q1 is the first charge, that is Q1 is the first charge. So then it is produce the electric field E1. So what is the equation for the E1? E1 equals to 1 by 4 pi epsilon naught, okay, Q1 by, so this is a source charge Q1 by R1P, okay, R1P square into R1P cap. So this is equation number 1. Next, second, electric field for E2 at R due to Q2 at R2 is, so E2 equals to, so 1 by 4 pi epsilon naught into Q2 by R2P whole square into R2P cap. So this is equation number 2. For Q3, for Q4, we are also written like E1 and E2 and E3 and E4 like that. So E1 bar, E2 bar. So then the superposition of, okay, by the superposition principle, of electric charges, electric field strength, the electric field, net electric field strength E, okay, net electric field strength E, it is electric field strength E due to at R due to the system of the charges, the system of these charges. So it is written as E bar equals to E1 bar plus E2 bar plus so on plus En bar. Okay, here then E bar equals to, so what is E1 bar? 1 by 4 pi epsilon naught Q1 by R1P square into R1P cap plus 1 by 4 pi epsilon naught E2 equals to, so Q2 by R2P square R2P cap. So it is a unit vector. So plus so on. So plus 1 by 4 pi epsilon naught into Qn divided by Rnp square into Rnp cap. Okay, so generally we can write this equation, the total net electric field strength. Okay, so E bar equals to 1 by 4 pi epsilon naught is common, sigma I equals to 1 to n. Okay, so Qn, first one Q1, Q2, Q3, Qn by, so what is 1 2 3, so then R I, what is common here, p square into, okay, RIP cap. So this is the general equation for the system of charges. Okay, electric field strength of a system of charges due to system of charges E bar equals 1 by 4 pi epsilon naught sigma or summation of I equals 1 to n Qn by I RIP square into RIP cap. So here E is the vector quantity that varies from one point to another point in a space. Okay, one point to another point in a space, it is varies, so it is the vector quantity. So our next topic is physical significance of electric field. So for example, we are consider a positive charge. This positive charge is influenced certain space, okay, of the charge is called the electric field. In this electric field, another charge we have taken Q2 plus Q2. What happens? So it is repulsive to each other. The repulsive force is occurred in between them. So Q1 and Q2. So in electrostatics, so we are consider this positive charge is in accelerating motion. Q1 is accelerated motion, then it produces electromagnetic waves. Electromagnetic waves with c speed, and reach Q2 and cause a force on Q2. So here it is accelerated motion of Q1. A source charge is acceleration motion. So then it is produce electromagnetic waves. These electromagnetic waves with a light speed in a free space, and it reaches Q2 and it causes a force on Q2. So this electromagnetic waves is carry the energy also, and a source of time dependent electromagnetic fields. Okay, here the a source of time dependent electromagnetic fields propagating certain direction and transport energy and this accelerated motion of q1 is also detect the electromagnetic waves. This is the concept of fields was first introduced by Faraday. So is now among the central concepts of physics. This is the electromagnetic waves is a physical significance of this electric field. When electric field is moves, okay, or a charge, source charge is accelerated motion, then it is produces electromagnetic waves and it transport the energy and it is detection, okay, it is detected of the electromagnetic waves, okay, it is detected and produce the electromagnetic waves. So then here this concept of electromagnetic fields or electromagnetic waves was first introduced by Faraday. This is the physical significance of electric field. So next topic is electric field lines. So this also called the electric lines of force. So here electric field lines are an imaginary path along which a unit positive charge would tend to move in electric field. So for example, we are consider a positive charge. So this positive charge is produces, okay, it is produces this positive charge, for example plus q is produces electric field. This electric field is like here, okay, and here also it is like some different positions, it is consist a different like okay. So these are the electric field strength, okay, the direction of this arrows are, okay, arrow mark is the direction of electric field strength. So this electric field strength E equals to, already we know that E bar equals to 1 by 4 pi epsilon naught into Q by R square into R cap. So here the Q is constant. So electric field strength is inversely proportional to the R square, the distance from the test charge, okay, a distance test charge is less, the field strength is large. The distance is increases, what happens, this electric field strength is decreases. The imaginary lines, the imaginary path along with unit positive charge would tend to move. So when we connect these points, these electric field lines, okay, electric field directions, so this is called the electric field lines. So this electric field lines also is called the electric line of force, okay, here electric field lines are also called as electric line of force. Okay, this electric line of force, a positive, it starts from positive charge and ends at negative charge. So then here, so we consider, so we can discuss here the properties of electric field lines. Properties. So what are the properties of these electric field lines? So first of all, the electric field lines starts from line of force. Line of force is starts from positive charge, ends at negative charge. Okay, for example, this is positive charge plus q, here negative charge minus q. So it is like this arrow mark. So positive charge, negative charge, the imaginary line, these lines are called the electric field lines or electric line of force. Second one, if there is a single charge, they can make starts or end at infinite. Okay, so for example, we are consider a positive charge. So here it is moves like here. The electric field lines is moves, it is ends at infinity. When we are consider negative charge, so it starts at infinity and ends at negative charge. These are the electric field lines. Okay, these electric field lines for negative free charge, so it is towards this negative charge from the infinitive, and when we have considered a free positive charge, it starts from positive charge and ends at infinitive. So fourth property is when a charge free region, okay, when a positive charge, so it is also positive charge free region, electric field lines can be taken to the continuous curves. So it is a continuous curves and without any breaks. So it is a continuous curves without any breaks. Here also we are taken like here, continuous curves without any breaks. So here positive charge, so then the electric field lines is outward direction from the positive charge. Here also outward direction from the positive charge. This is one of the property. And fifth one, so when we have taken a positive charge here and here it is negative charge, so the electric field lines is moves from positive charge to negative charge. So then here the electric field lines, here also we have taken electric field lines here like here. These are the electric field lines. Okay, it is moves like here. Okay, so the direction from positive charge to negative charge. positive charge to negative charge. Here in this electric field lines we can draw at any point a tangent. So this point, a tangent. This tangent is indicates the direction of the electric field strength. Okay, at any point we can draw a tangent. The tangent at any point to the curve gives the direction of electric field strength at any point. Okay, so this is sixth one. At any two field lines do not intersect. At any two field lines, any two field lines are do not intersect. So because at any field lines, for example, this is one field line, this is another field line. So it is positive, it is negative, it is positive and negative. At this intersection point, what happens? At this intersection point, it consists compulsory two directions of electric field, two directions. So but it impossible. So because it consists unique direction. Okay, at any point to the tangent we can draw the tangent. So then it consists only one direction of electric field. So then any two field lines do not intersect to each other. Next, seventh one. Electrostatic field lines do not form any closed loops. Okay, here seventh property is electrostatic field lines do not form any closed loops. But in magnetism, the magnetic field lines form the closed loops, but here in electrostatic field lines do not form the any closed loops. Here starts the electric field lines is starts at a positive charge and ends at negative charge. Okay, it is ends at negative charge and starts at positive charge. Next, last one, eighth one. So when if the number of field lines passes through here, for example 1 centimeter square. So we are consider, so this is the area. The area is 1 centimeter square. This unit area, the number of electric lines, okay, electric field lines are passes, the number of is more, then the field is a strong field. The electric field is strong field. When the number of electric field lines is passes low, okay, low, then less, then the field is called the weak electric field. So then the number of electric field lines is passes through the unit area, it is indicates that it's a strong electric field or a weak electric field. The number of electric field lines passes more, it is strong electric field. The number of electric field lines is passes through the unit area less, So it is called the weak electric field. So this is about the electric field lines and the properties of electric field lines. In next so this is the end of the class. Next class we will discuss electric flux and certain concepts of electric dipole, the applications of electric dipole. So like that. Thank you.